0.3. So we're looking at learning some new properties of exponents. So here's a little warm-up, just real quick. So exponents mean that repeated multiplication. So a to the fifth means I have 5 a's, 1, 2, 3, 4, 5. A to the third means I have 3 a's, 1, 2, 3. And then here I'm dividing, so I'm dividing all those 5 a's by these 3 a's. Remember, whenever we're dividing by the same thing, 3 over 3, it's 1, or 10 over 10, it's 1. So a over a becomes 1, so I can cancel out those a's, cancel out those a's, cancel out 3 of the a's, and I'm left with a squared. Same thing here. You can do that. And if I have more on bottom, that means I have more on bottom, so this would be a squared on bottom. So what's a faster way to do this? So when we multiply by the same base, we add exponents, right? So what happens when we divide by the same base? You can think about that. Well, that is really subtraction. So we get a to the negative 2. Well, a to the negative 2 is the same thing as also a to the 1 over a to the positive 2. And so that's what we're going to learn about today. So here are the division properties of exponents. So whenever we divide by the same base, we subtract, and it's always top minus the bottom exponent. So top minus the bottom exponent. And then here are some examples. Even if you get complicated fractions, we just have to subtract fractions. So again, we need common denominators for that. Okay, so here's first example. Go ahead and get it down in your notes. Highlight that. And so here we go. So we are dividing. So we're dividing. We do have the same base. So again, it has to be the same base. We're dividing. So we can go ahead and subtract those exponents. I know these exponents suck because look, it doesn't have the same base. So I can get to the same base because that really is 2 over 1. So I can multiply top and bottom by 2. So that'd be 4 over 2. And now I have a common denominator. So now I can subtract and I get 1/2. And so there's my answer. Go ahead and highlight that. Okay, here's one, add a little bit more to it. Now we have two different bases, m and m, and we're dividing. So we go ahead and subtract those exponents, top exponent minus bottom exponent. We got another base n on top and bottom, so it has to be the same exponent, or same base. And then we take those exponents, and since we're dividing, we subtract top minus bottom. And then after that, we get a -3, and then n is just positive 1. You don't have to put that one. Okay. And then we can't combine after that. Okay, so here's the next one. Dividing in scientific notation. So kind of same thing before. A little bit added on because now we have these numbers out in front. Right, you don't have to highlight this part, but we have those numbers out in front that are gonna not really complicate things, but it's really just kind of dividing here. So we're gonna take these two and we're gonna divide them. So population density describes the number of people per is division, unit area. So which one of these is people? We're going to do people divided by area. So this one's people and this one's square miles. This is just units. That is not like an x and a y. It's just units. So we don't have to put that in our problem here. So we have 1.21 times 10 to the 7th all over 4.81 times 10 to the 5th. Well, I don't know off the top of my head what 1.21 divided by 4.81, but just like multiplication, when we multiplied these, we just multiplied these coefficients. Well, now that we're dividing, we're just going to divide those coefficients. 1.21 divided by 4.81. And then since we're dividing these tens, they're like bases, so we can go ahead and subtract those exponents. So 7 minus 5, and we get 10 to the 2nd. And I don't know what the top of my head is off that. So we get 0.25, 2.252. Okay, and so this, I go ahead, that is not a number between 1 and 10, so I need to move that decimal, and since I move it over 1 to the right, I make it bigger, 2.52. So that means I need to take this exponent and now make it smaller, because I made that side bigger by 1. I need to make this side smaller by 1, so I got to move that exponent down. So here's my answer in scientific, that's a positive one now, in scientific notation. Okay, now we're pretty much going to go back through the other properties that we learned. So we learned multiplying by the same base, we add exponents, and then we learned some more and added to that. So now we're going to start with, well, when we divide by the same base, we subtract exponents, and now we're going to add those others. So before we had product raised to a power, now we have quotient raised to a power. So when we have a fraction, that's what it means by quotient, a fraction raised to a power, we can take that exponent and distribute it to the exponents of the two bases. So here's a few examples. So 3 is the exponent, so it's going to go to the exponent of the 3 and the 5, and then you can go ahead and use your calculator to do those. And same thing with a's and b's and x's and y's. So that exponent gets distributed to the exponents. Okay, so here's an example. You can highlight this. Okay, so you can pause it and try to figure out what this is. You can do it by yourself. I'm about to do it right now. So this 3 is going to get deposited to the exponents. So it's going to go to this exponent. And then it's going to go to this 5. That's a z. It's going to go to this 5 as an exponent. So that's 5 cubed, and 5 times 5 times 5 is 125. So our answers is either here or here. And then we're going to multiply this 2/3. Well, we can cancel those 3's because we're multiplying by 3 and dividing by 3, so those will cancel. We can just get 2. So z squared over 5 times 5 times 5 is 125. So it is this one. And we'll probably just do this one in class. So here's the next one. Let's go ahead and highlight that topic. And so now we're just going to add to it, right? So now we got more. So now we got a product in here. Right there's 2 times x, right? So this -3 is going to go to the exponent of the 2, of the exponent of the x, and the exponent of the y. It's going to go to all of them. So 2 to the -3. Okay, that's 2 times itself 3 times. Don't think about the negative right now. We'll deal with that later. 2 times itself 3 times. And then the x to the 6 is also going to get that -3. And then the y is also going to get that -3 as an exponent. And we already have an exponent on these 2 spots, so we just go ahead and multiply. So just keep that 2 to the -3 there. This is -18. This is y to the -12. All right, so the last thing we're going to talk about, since this is still under 10 minutes, so we'll go ahead and add to it a little bit. So I've told you before with those like 2 to the -3, we're just going to go ahead and leave it as 2 to the -3, not deal with the negative. Well, now we're going to start addressing those negative exponents, okay? So this negative exponent rule, we kind of saw it at the very beginning, how we had 2 to the -2, and that was the same thing as 1 over 2, or maybe it was an a. I think it was an a to the -2, and it became a to the +2 on bottom. So the negative exponent rule just says that whenever we have a negative exponent, we can go ahead and just put a 1 on top and then change that to a positive. Now when I say 1 on top, I mean on top of the whole thing. So the only thing I'm changing in my exponent is from positive to negative. So I have a negative exponent, so if I want to make it positive, I move it to the denominator. So right now it doesn't have a denominator, so you can put a 1 on it, and so this whole thing will flip, and then it will change from a negative to a positive. Okay, so the only thing we're changing on the exponent is just the sign, okay? But the whole kind of fraction is flipping. So, and why this is the case, because 2 squared is 4. If I go 2 to the 1, if I decrease by 1, that's taking 4 and dividing by 2, right? Because if I increase, then I'm multiplying. If I want to go up, I multiply this by 2, and I get 8, so 2 to the 3rd is 8. If I want to go down, I divide by 2, and I get 2. So what's 2 to the 0? Well, that's 2 divided by 2, which is 1. So if I go down 1, 2 to the -1, I would take 1 and divide it by 2. 2 to the -2, well, I would take 1/2 and divide that by 2, which is the same as multiplying by 1/2, which is 1/4, which is the same. 4 isn't the 4 the same as 2 over 2, or 2 raised to the 2. So notice that negative exponent now gets put in the denominator. So I flip the whole thing. So how this works out, trying to keep it under 10 minutes here, is whenever you have a negative exponent, you can make that positive. by putting a 1 underneath. You can put a 1 underneath the whole thing and then flip it, or you can just put a 1 on top and change the exponent sign to positive. So either way is fine. So the last thing real quick, just over 10 minutes, is if you have a fraction, say a over b, and that's raised to a negative exponent, what we can just do is flip that fraction on the inside. So if we flip that fraction on the inside, put b over a, then we can just change that to positive 2. Okay, so that's really nice, because then we just flip the whole entire inside. Bottom goes to top and top goes to bottom. And then one last one, kind of throwing this at you fast, but try to start working on these. And then the last one, let's see, is if I have m to the negative 2 and say x squared y to the negative 3, I can move these. So that's a y to the negative 3. If I want a positive exponent, I can just put that y on bottom, and now it's positive. And if I want this m to the negative 2 to be a positive exponent, I can put that m on top, and now it's positive. So I just move between numerator and denominator only of the ones that have negative exponents. All right, that's it.